Hello learners, welcome to Neenv. We are discussing science and technology mains PYQs. So the topic here is space science. All right. So let us see the question. The question was asked in 2022. The question says launched on 25th December 2021. So let's say 1 year previous current affairs. James Webb Space Telescope has been much in news since then. So directly from current affairs it has been picked up. What are its unique features which make it superior to its predecessor space telescope? What are the key goals of this mission? What potential benefits does it hold for human race? So three parts are there, right? So understanding the question directly picked up from news, like I said, it is asking what potential benefit to human race. So have a very global view rather than having a parochial view. Like say, don't focus just on India, focus on the world also. So straightforward question. So briefly detail all the key findings, development on JSWT that makes it superior, details about the goal of the mission and significance, right? And we'll conclude accordingly. All right. So it was launched on 25th December 2021, and significance is that it is a major advancement in observing the universe, and it has surpassed the Hubble Space Telescope in size, optics, and sensitivity. We'll see a few images which will tell you the scope of this. Which will tell you the scope of this telescope, right? So what are the unique features? The first section is infrared vision, because of which basically it can now track in the dust also, dust clouds. So it detects the infrared radiation unlike the Hubble telescope, which observes visible and ultraviolet light. So because of this, it can peer through or it can see through dust clouds, because of which it can reveal hidden celestial objects under the cloudy nature of the universe. Larger primary mirror. Now you can imagine, if you can, I'll show you. So the size is 6.5 meters in diameter, much larger than Hubble's 2.4 diameter mirror. Advantage is, of course, the bigger the mirror, the bigger the light will be captured and better the image. So achievement is it has delivered the deepest and sharpest infrared image of distant universe, that is SMAC 0723 galaxy cluster. We'll see the image. So this is the size comparison. This is the human. This is the human, and this is the Hubble primary telescope mirror, and this is the James Webb telescope primary mirror. So as you can see the size difference, right? Let's move ahead. So this is the SMAX 0723. It's a cluster of galaxies. This was on the right hand side, it was captured by Hubble telescope. As you can see, not many details are there, but here you can see lot of stars are available. I request you to explore this on internet. You will find much clearer images if you're not able to see them right here. But on the left hand side, the James Webb telescope has much clearer, better images, right? Next thing is unique feature. It is orbiting the sun at the L2 point, the Lagrange point 2 over here, right? Now the benefit of this is that it is at a very stable position where the heat of the earth and the sun is not affecting it much, because of which it can take sensitive collections of information. So this is very important, again, the position at which it was put. Right, stable thermal environment is provided. Next is sun shield. Its shield from the sun is as large as the size of a tennis court. Just imagine a tennis court, that big is the heat shield of this telescope. So it protects it from the sun heat and light, because of which it can maintain low temperature for infrared instruments. Advanced instruments are there: NIR CAM, NIR SPEC, MIRI, FGS, NIR, ISS. Now these are state of the art instruments for capturing images. State of the art means the best of the best. They analyze light and study the planetary systems. Now you don't need to know these technologies. Even if you don't write the name, that's okay. What are the key goals of this mission? It wants to detect the early universe light. So it wants to observe the first stars and the galaxies that formed after the Big Bang. So basically, like I said, it wants to see the first light of the universe. So it wants to provide insights into the evolution, how things developed after the Big Bang. Next is galaxy and star formation. It wants to know how they formed. We know it theoretically, but it wants to observe, right? Especially in the dust shrouded regions. That means the places where dust is still there. All right. Exoplanet characterization. That means it will try to detect planets which have life, or let's say atmosphere similar to ours. So it will study the atmosphere, searching for biosignature like water, methane, and oxygen. Next section, potential benefits for humanity. Now, if you have not heard about dark matter and dark energy, you will soon see that in one of our videos. But dark energy has baffled our understanding of the universe, and this telescope, although it will not see the dark energy, but it will help us in understanding other areas of universe also. So it wants to do the fundamental discovery, like how universe works, formation of galaxies, stars, planet, cosmic origin of things, and potential of life elsewhere. Next is technological advancements. Many times things are not available when we want to do a project, so we create new things that leads to innovation. So that thing, innovation in optics, material science, cryogenics, application beyond astronomy such as in medicine and energy. So these things that have been developed for James Webb Space Telescope, such things will of course somehow motivate or inspire innovations on Earth, inspiring future generations, because since JWST will click better photos, it will create curiosity in the mind of young people to explore and learn science as a hobby also and as a career also. International collaboration, because this is a collaboration between NASA, European Space Association, and the Canadian Space Association. So again, this is a benefit for humanity that people are collaborating on such a huge project. Stimulus for the space industry. Of course, whenever you develop such things, whenever you develop such photos, private concerns might also get involved. Hence, it leads to more jobs. Cultural impact. The Hubble Space Telescope gave us first images that we saw of the space beyond our galaxy, right? So all these things motivate people to have telescopes to observe meteors, things like this. So this will also hopefully do something like that. So what is the conclusion? See, this telescope represents a pinnacle, that means a high point of human ingenuity and scientific ambition. So it will reshape our understanding of the cosmos and inspire future generation. So that is a thing, right? So this is the image I wanted to show you. This is called Southern Ring Nebula. This detail is captured by the James Webb, and this is by the Hubble telescope. So you can see the difference between the images itself. How much detail is there? How much color is there? Right? How much light is there? Right? Okay. So I hope you understand the James Webb telescope. I hope you appreciate the importance. Right? So that is all for this question. Thank you.